identity matrix. Let I be the n by n identity matrix, then AI is equal to IA is equal to A for any n by n matrix A. So from that statement, we can easily see that an I matrix is a square matrix, and that if I multiply an I matrix, a square matrix, n by another n by n matrix A, I'm going to get back I'm going to get back the matrix A. So in other words, multiplying by the I matrix is the equivalent of multiplying by one, of multiplying a number by one. When you multiply a number by one, it does not change. So if I multiply an I matrix, an n by n I matrix, by an n by n matrix A, I'm going to get back the matrix A. So the identity matrix is the matrix whose leading diagonal consists of ones, and all other elements in the matrix are zeros. So the leading diagonal is the diagonal from the top left-hand corner to the bottom right-hand corner of the matrix. So here, the 2 by 2 identity matrix is 1, 0, 0, 1. The 3 by 3 identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. Example 15. Now, in example 15, we're told let A be the matrix 2, 1, minus 1, 1. We're to find A squared plus A plus 2I, where I is a 2 by 2 identity matrix. So let's start off by finding A squared. When you square something, you multiply by itself. So A squared would be A multiplied by A. All right, so of course, every time we multiply, whenever we multiply two matrices, we multiply the rows of the first matrix by the columns in the second matrix. And every time we multiply a row by a column, we get an answer, we get an element in the answer. How do we multiply a row by a matrix? We multiply the first element in the row by the first element in the column, then the second element in the row by the second element in the column. So let's do that now. So I'm multiplying the top row by the left column. The first element in the top row is 2. The second element in 1 is 1, multiplied by the left column. The first element in the left column is 2, and the second element is minus 1. So I'm going to multiply 1 by 1 and 2 by 2. So 2 2s are 4. 1 times minus 1 is minus 1. All right, so I just multiply the top row by the left column. Now I'm going to multiply the same top row, but now by the right column. 2 times 1 is 2, and 1 times 1 is 1. So next, I'm going to multiply the bottom row by the right column, and that will give me the bottom right element. So it's 1 times minus 1 minus 1. 1 times 1 is 1. Same bottom row, but this time now by the left column. First element in a row by the first element in a column. So it's minus 1 times 2 is minus 2. And 1 times minus 1 is minus 1. So A squared would be the matrix 3, 3, 0 here, and minus 3 here. That's the matrix A squared. So now let us find A squared plus A plus 2I. Of course, the I matrix, the 2 by 2 I matrix would be 1, 0, 0, 1. All right, so now I'm ready to find a squared plus a plus 2i. So a squared plus a plus 2i would be, first of all, a squared, which is 3, 3 minus 3, 0. That's a squared plus a, which is 2, 1 minus 1, 1 plus 2 times I, 1, 0, 0, 1. All right, so um, now when you're adding matrices, what you do is that you add corresponding elements. Corresponding elements are elements which are in the same position. So it's going to be 3 plus 2 plus 2. That's the top left element, top right element, 3 plus 1 plus 0. Bottom left element, minus 3, that's minus 3, plus minus 1, which is minus 1, plus 2 times 0, which is 0. Bottom right would be 0 plus 1 plus 2 times 1, which is 2. And so our final answer would be 7, 4, minus 4, 3. So if A is the matrix 2, 1, minus 1, 1, A squared plus A plus 2i, where I is the 2 by 2 identity matrix, is equal to 7, 4 minus 4, 3. Example 16. Example 16 says, given that A is matrix 1, 1 minus 1, 0, 1, 1, 0, 0, 1, we're to find the matrix A squared, then A cube, then we're to find 2A cube plus A squared plus A minus I, where I is the 3 by 3 identity matrix. All right, so we need to get all of it done on this side. So let's start out by finding I squared. Sorry, A squared. A squared would be A multiplied by A. So we're going to multiply a row by a column. Row by a column. So this is the top row, first, second, and third element, left column, first, second, and third element. So 1 by 1, 2 by 2, 3 by 3. So 1 times 1 is 1, 1 times 0 is 0, and minus 1 times 0 is still 0. Top row, left column, middle column. One times 1, 1, 1 times 1 plus 1, minus 1 times 0 is 0. Top row, right column. One times minus 1 is minus 1. 1 times 1 is 1. And minus 1 times 1 is minus 1. All right, so I just multiply the top row by the 3 columns on the right. So next I'm going to do the same with the middle row. All right, I'm no longer going to put in these numbers because if we do, they'll just take a serious amount of time. So middle row, left column, 0 times 1, 0, 1 times 0, 0, 1 times 0 is 0. So this is just 3 zeros, zeros plus 0 plus 0, which is just 0. Middle row by middle column, 0 times 1, 0. 1 times 1 is 1. 1 times 0 is 0. So this is 0 plus 1 plus 0. Middle row, right column, 0 times minus 1, 0. 1 times 1, 1. 1 times 1, 1. So this is 0 plus 1 plus 1. Bottom row, left column, 0, 0, 0. Bottom row, middle column, 0, 0, 0. Bottom row, right column, 0, 0, 1 times 1, 1. And so our answer here would be 1, 2, minus 1, 0, 1, 2, and 0, 0, 1. All right, so that is what we get when we multiply a by a. So that would be a squared. Now a cube, I'm guessing, is a squared multiplied by a. So a cube will be a squared, 1, 2, minus 1, 0, 1, 2, 0, 0, 1, multiplied by a, which is 1, 1, minus 1, 0, 1, 1, 0, 0, 1. Top row, left column, 1, 0, 0. So this is 1 plus 0 plus 0. Top row, middle column, 1, 2, minus 1 times 0 is 0. Top row, right column, minus 1 plus 2 minus 1. So it's minus 1 plus 2 minus 1. All right, bottom row, left column, 0 plus 0 plus 0. Middle row, middle column, middle row, middle column, 0 plus 1 plus 0. Middle row, right column, 0 plus 1 plus 2. Bottom row, left column, 0 plus 0 plus 0. Bottom row, middle column, 0 plus 0 plus 0. Bottom row, right column, 0 plus 0 plus 1. All right, and so our final answer here would be 1 here, 3 here, 0 here, 0 here, 1 here, 3 here, 0, 0, and 1. So that would be a cube. So the last thing now for us to do is to find 2a cube plus a square plus a minus I. All right, so we're going to multiply the matrix A cube by 2. To do that, we simply multiply all the elements in A by 2. So 2A would be 2, 6, 0, 0, 2, 6, and 0, 0, 2. That would be 2. All right, let's make it a little smaller. We might need the space. All right, so 2A would be 2, 6, 0, 0, 2, 6, 0, 0, 2. That's 2A cubed plus a square. A square is 1, 2, minus 1, 0, 1, 2, 0, 0, 1. That's a square plus a. A is 1, 1, minus 1, 0, 1, 1, 0, 0, 1. Now minus 2 times, sorry, minus just I. And I is the 3 by 3 identity matrix. So it's 1, 0, 0, 0, 1, 0, 0, 0, 1. All right, so let's work this out. When you add in 2 matrices, you add corresponding elements. So it's 2 plus 1 plus 1 minus 1. In the middle, I have 6 plus 2 plus 1, 6 plus 2 plus 1 minus 0. And to the right, we have 0 minus 1 minus 1 minus 0. All right, so the top row in the answer would be 3. 8 plus 1, 9. Minus 2. Oops, minus 2. Middle row, I have 0 plus 0 plus 0 minus 0. Middle, I have 2 plus 1 plus 1 minus 1. Middle right, I have 6 plus 2 plus 1 minus 0. So here would be 0, 3, 9. Bottom row, 0 plus 0 plus 0 minus 0. Middle, 0 plus 0 plus 0 minus 0. Right, 2 plus 1 plus 1 minus 1. So it's 0, 0, 3. All right. Let's turn the page. Example 17. Example 17 says that D is the matrix 2, 0, 0, 2. We're to find D square. So let's start out with D square. D square means that you multiply D by itself. So it's 2, 0, 0, 2 times 2, 0, 0, 2. Row by a column, top row left column, 2 times 2 is 4, 0 times 0 is 0. Top row right column, 2 times 0 is 0, 0 times 2 is 0. Bottom row left column, 0 times 2 is 2, 2 times 0 is 0. 0 times 0 is 0, 2 times 2 is 4. So D square would be 4, 0, 0, 4. Next, we have to find D cube, which would be D square multiplied by D. D square would be, D cube would be D square multiplied by D. Two, 4 times 2 is 8. 0 times 0 is 0. 4 times 0 is 0. 0 times 2 is 0. 0 times 2 is 0. 4 times 0 is 0. 0 times 0 is 0. 4 times 2 is 8. So D cube would be 8, 0, 0, and then 8. All right. So B now is asking us to deduce D to the n, D raised to the n power. All right, so far what we have seen is that D squared is actually equal to 2 squared, 0, 0, 2 squared, and that D cube is 2 cube, 0, 0, 2 cube, and that's by observation. So we could reasonably conclude that D to the n would be 2 raised to the n power 0, 0, 2 raised to the n power. All right.